In this video, we're taking a look at the Pythagorean Theorem. The Pythagorean Theorem is actually a fact about right triangles that was discovered by a Greek mathematician and philosopher named Pythagoras. What it states is that when you square the legs of a right triangle and you add them, it is equal to the square of the hypotenuse. Here's a diagram. This is a 3, 4, 5 right triangle. We've squared the leg that measures 3, and we've squared the leg that measures 4. When you add them, 3 squared is 9, 4 squared is 16. When you add them, you get 25, and you'll notice the diagonal, which measures 5, when it is squared, 5 times 5 is 25. So again, the Pythagorean theorem states that a squared plus b squared equals c squared. Or you could say the leg squared plus the other leg squared equals the hypotenuse squared, or the diagonal. Let's take another look, or let's first take a look at the definition. This is the actual definition. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. And again, here's another diagram. You'll see this is the right triangle, and the two legs make an L, or the two sides make an L, so we call them legs. This is leg 1 or leg 2, and we assign one of them an A and the other one a B, and then we call the diagonal the hypotenuse. And in the formula, the hypotenuse is given a C. So it's a squared plus b squared equals c squared. Let's look at a couple more diagrams where we just simply model the Pythagorean theorem. Here's a right triangle. And again, the two shorter sides, which make up the right angle, the legs, one measures 6, one measures 8, and one measures 10. Let's see. Let's take a look at the theorem. Again, it says that a squared plus b squared is equal to c squared. So our first leg we could call 6, and we're going to need to square it, plus 8, and we're going to square it, equals 10 squared. Of course, by squared, I simply mean make it a square. And to find the area of that, it's 6 times 6, or when we square 6, we get 36. So that's 36 plus. Then we also square 8. When we square 8, that is going to be 8 times 8, which is 64. So 36 plus 64 equals, and then we square the c, or the hypotenuse, and that is going to be 10 times 10, which is 100. So you can see that 36, or a squared, plus 64, or b squared, is equal to 100. 36 plus 64 is 100, and the left side of the equation says 100, and the right side of the equation says 100. So this is a model, or this is modeling the Pythagorean theorem. Again, right triangles, two legs, and a hypotenuse, square them all, and the two legs added together equals the diagonal. Let's look at another example. This is a triangle where one side measures 5 units, the other one measures 12, and the diagonal, or the hypotenuse, measures 13. Again, same formula, 5 squared plus 12 squared equals, and our hypotenuse is 13 squared. So we're going to square the sides, or the legs, the two sides that make up the right angle. And then 5 times 5 is 25. 12 times 12, or 12 squared, is 144. And then 13 squared is 169. So let's see if the two legs, let's make sure let's make sure this is true. 5 squared, 5 times 5, plus 12 times 12 should be equal to 13 times 13. 5 times 5, or 5 squared, is 25, plus 12 times 12 is 144. And this side equals, let's see, 125 plus 144 is 169. And you'll notice on the right side, 13 times 13, or 13 squared, is 169. So you have the left side equaling the right side. So in this video, we have looked at modeling the Pythagorean theorem. In some videos to come later, we're going to use this Pythagorean theorem to solve the triangle, or to determine the measurement of one of the sides of the triangle. Will be given 2 and determine the third. But this is just modeling the Pythagorean theorem, where you square one of the legs, square the other legs, add them together, and that's the square of the hypotenuse, the Pythagorean theorem.